Okay, so today we will be continuing, this is an introduction continuing tutorial 5. But it's mainly tackling the final question of tutorial 5, which is actually rolling without sleeping. The most important thing that I want to say here is that rolling without sleeping is quite a deep concept. Not deep, it's quite a simple concept, but it requires understanding, and it requires a bit of a lubrication towards the whole thinking process, so that you can know what you are doing. So today, I am actually going to describe to you the whole principle of rolling without sleeping. There's actually mathematical equations involved, to be honest. Yeah. And apart from knowing what rolling without sleeping is, we will also use this understanding to develop an equation for a wheel rolling without sleeping on the floor. And basically all the instantaneous, what is it called, velocity, instantaneous center rotation things, we will just flow on the way as we describe this thing. So before this, let me do a bit of recap. What do we learn in tutorial 5? We basically introduce a very simple equation. The equation is that VA is equals to VA slash B plus VB. Okay? And also, in the acceleration term, AA is equals to AA slash B plus AB. Now, please take note, this equation is only usable in one component. It's only very useful in one situation. And the particular situation is that when both points A and B are situated on the same body. Why is it so? Because if 2 points A and B are both situated on the same body, this equation, we will have a, we will have an information on VA slash B and AA slash B. In other words, when 2 points are on the same body, the only possible motion in terms of relative motion is a circular motion. In other words, if this is A, this is B, velocity of A with respect to B and acceleration of A with respect to B will be a circular motion because A and B is always in a fixed distance apart. When something is a fixed distance apart from you, the only way that object can move in your perspective is a circular motion because the distance between you would not change. So please remember, do not anyhow use these two equations. Only use these two equations if both points A and B are on the same object. Now, with that understanding in mind, let's take a look at what does it mean by rolling without sleeping. So, let me give a very simple example. Let's say I have two objects, object 1 and 2 here. And they are basically rolling without sleeping at this point here. And let this point be point A. They are rolling without sleeping at this point here. But as I said, all points must belong to a body. Makes sense, right? Because all bodies are made out of points. So actually, it's incorrect to say there's only one point at this connection, rolling without sleeping point here. To be exact, there is 2 points. One point which belongs to body A1, and the other point belongs to body 2. So let's say this point here, point A1 belongs to body 1, point A2 depends on belongs to body 2. These 2 points, these 2 bodies are rolling without sleeping at point A here. Now, according to the concept of rolling without sleeping, when 2 bodies are rolling without sleeping at a particular point here, of course, as I mentioned, there is no one point, there's only 2 points. One point belongs to A1, one point belongs to body 1, one point belongs to body 2, but they are both rolling without sleeping at a particular intersection. And according to the formula and understanding, the velocity of point A1 must be equals to velocity of point A2 when these 2 bodies are rolling without sleeping at a point here. Okay, that's the first understanding. It means that, see, a body is made of a lot of points, right? And each point has its own velocity. It's possible for each point to have its own velocity. The velocity of A1 here must be equals to the velocity of A2. It means that if today A1 here, this point here, the point of rolling without sleeping, is going in this direction, VA1. It means that VA2 must also be going in this direction and has the same magnitude. Okay? So that's what it means that velocity must be the same. The velocity of the rolling without sleeping points must be the same. That's the first takeaway. Now the second understanding was a bit more it's a bit more obscure. It's not that clear. But please take note. The second equation, the second condition is that at the point of rolling without sleeping, the acceleration of the point belongs to one body which is tangential to the plane of rolling without sleeping is equals to the acceleration of the point on the other body, which is tangential towards the plane of acceleration without slipping. Now, first misconception, first thing first, please do not misunderstood. I am not saying acceleration of A1 is equals to acceleration of A2. This is not what I'm saying. This is not true. First of all, when both bodies are rolling without slipping upon each other, acceleration of A1 does not have to be equals to acceleration of A2. However, let's just give a very simple example. Assuming today we know that acceleration of A1 is in this direction. And assuming that we know acceleration of A2 is in this direction. Now, as we all know, accelerations are vector quantities, and vector quantities can be resolved to different directions. Now, assuming that at the intersection point here, I fit a tangential plane, which is denoted by this green color line. This tangential plane was fitted along the point of rolling without slipping. Now, what I can do is that I can resolve this acceleration into two different components. One component is along this rolling without slipping plane. The other component is normal to it, right? So this A1 I can resolve to this direction and this direction. This direction is just A1 normal. This is basically A1 tangential to the rolling without slipping plane. Please take note, this T and N here has nothing to do with circular motion. Nothing to do with circular motion. It's only that this T here is tangential to is the component of this acceleration tangential to this rolling without slipping plane. At the same time, I can resolve acceleration A2 into this direction, which is normal to the rolling without slipping plane, and tangential, acceleration A2T, tangential to the rolling without slipping plane. And according to the formula, acceleration of A1 tangential must always be equals to acceleration of A2 tangential. This doesn't have to be equals to this. However, this must be equals to this if these 2 points were to be rolling without slipping at point A. Okay? So please take some time and digest this understanding, because by understanding this what is called component, we are going to talk about how do we derive the rolling without slipping case for a solid circle, solid cylinder on the what is it called floor. So now let's take a look at the derivation. Okay. Now let's see how do we do the derivation based on understanding. So first of all, to derive a rolling without slipping case, we need to have 2 points, right? So what we're trying to prove here is that why is this the instantaneous point of rotation? Why is this point A here 0? So let's say there's a point here, A, and we all know that this point is instantaneous center of rotation of the body, right? And we know that this point O is center of gravity. So today what we are going to prove is why is O, what is it called? Why is the velocity of O equals to R omega? And why is this part the instantaneous center of rotation? Let's do the proof. And we'll learn a lot of things about it. Now, assuming today, my cylinder or this wheel is moving to the left. Moving to the left. Okay? It's moving to the left. So if I'm moving to the left, it means that there's this thing here. There's this thing here. So this is velocity of g. So let's just put this as g. 0. Okay. Now, this point here is basically this cylinder is rolling without slipping about the point A. Now, please take note. First of all, first misconception. At this intersection point here, at this what's contact point here is the contact point between the wheel and the ground. So it means that there's actually 2 points here, right? One point is point A, which belongs to the wheel, and the other point is also point A prime, which belongs to the ground. According to the principle of rolling without slipping, velocity of A must be equals to velocity of A prime. Now please take note again, A belongs to the wheel and A prime belongs to the ground. Now apparently the ground is not moving, so if the ground is not moving, we can straight away say that velocity of A is equals to 0. Right? That's the first thing. And assuming that this whole body was rotating in a counterclockwise direction with an omega, or which what is called with an angular velocity of omega, velocity of g is equals to velocity of g with respect to a plus velocity of a, right? Because velocity of a and velocity point A and point G are on the same body. When both points are on the same body, I can utilize this equation. Now velocity of g is equals to, now velocity of g with respect to a. In a perspective, what is g's motion? In a perspective, g is going in circles about a, because it basically has a fixed distance. So in that case, we know that vg slash a is equals to rag, in other words the distance from a to g, rag, times omega. How about the direction? Now because this body is going in a counterclockwise direction, so apparently the whole omega is counterclockwise, so in a perspective, g is going in this direction, right? So if it's this direction, it means that the velocity of g in a's perspective is going here. This direction apparently is 180 degrees. So what is VA? We have proved that VA is 0 because of the rolling without slipping condition. So this is 0. So apparently we proved that velocity of g can be calculated by just r omega. That's the first thing. Okay. Now, how about the acceleration of g? Now this is something that's very interesting here because most people, so for all of us, we know that velocity of g is r omega. And we also know, due to the physics course we learned in year 1 or year 2, acceleration of g is equals to rag alpha, right? And the direction in this case is also 180 degrees if today alpha is in this direction. So why is this equals to rag alpha? Is it because this is an instantaneous center of rotation? So it's r alpha? The answer is no. Please take note of this. Instantaneous center of rotation can only provide you the velocity information. The distance between the instantaneous center of rotation with the concerned point multiplied by the omega or angular velocity of the body will give you the velocity. However, distance from the instantaneous center of rotation to the concerned point times the angular acceleration of the body would not give you the acceleration except for a wheel rolling without slipping on the ground. This is actually a very special case. The reason why this thing can be represented in this form is not because this is the instantaneous point, but because the ground is not moving. Why do I say so? Now let's make a proof. Let's just say y ag is equals to rag alpha. We can prove it easily. So we know that since a and g and a are on the same body, we can just do the same thing. Ag is equals to ag slash f a plus aa. Right? So what is ag slash a? So acceleration of g in a perspective is a circular motion. So definitely there's two components, centripetal and tangential. The centripetal acceleration can be denoted by omega squared rag. Right? Which is, of course, is in a perspective. So g is going in circles about a. So the centripetal acceleration should be pointing towards a because a is the center of rotation. So pointing downwards, it's actually negative 90 degrees. Now, plus alpha and the tangential acceleration of g in a perspective, which is equals to alpha rag direction of, assuming alpha is this direction. So this is actually just 180 degrees. So this is your ag slash a. Okay? Plus now, acceleration of a is very interesting. Acceleration of a is very, very interesting. So, how do we denote the acceleration of a? So, I mean, most of you, when you look at the professors' what is called labs, they immediately tell you that acceleration of a is pointing upwards. Right? So, I'll show you. Now, why is the acceleration of a pointing upwards? Now, let's take a detour first and just take a look at why it is so. So, assume this situation, let's assume this situation. Assume that we do not know what is the acceleration of a direction and we don't know the magnitude. So we just simply assume that the acceleration of A is this direction. We should assume first. If the acceleration of A is this direction, it means that we can split to two directions, right? We can split to here, which is AAT, and we can split to here, which is AAN. Now, this body and the ground is rolling without slipping. According to the case of rolling without slipping, the tangential acceleration with respect to the rolling without slipping plane of A must be equals to the tangential acceleration of A prime along the rolling without slipping plane. Means that AAT must be equals to AA prime T. But apparently, A prime is not moving, so this will be 0. If this is 0, according to the rolling without slipping condition, AAT must also be 0. So in other words, only this is a number, or have a certain value, so it means the acceleration of A can only be pointing upwards. That's the one thing we know. So in this case, we can proudly say that acceleration of A is having a component of 90 degrees. Let me repeat. Why do we know it's pointing upwards? Because first of all, acceleration of A cannot have any horizontal component because the horizontal component is along the plane of rolling without slipping, and the point which belongs to the ground has no acceleration component at all. In other words, the point on the ground, A prime, does not have an acceleration component along the rolling without slipping plane. Hence, the point A here also could not have an acceleration component along the rolling without slipping plane, making it only have an acceleration component perpendicular to the rolling without slipping plane, which means that the acceleration of A must be 90 degrees, right? Because AAT is 0, right? So means AAN is basically the direction of A. So now, from this understanding, we can also do a bit of shortcut. What is acceleration of G? Acceleration of G, we do not know the magnitude. However, we do know that acceleration of G must be going to the left, right? Because when something is turning, G must always go horizontally. So this is definitely in the 180 degrees direction. Now, if you dot product the whole thing, dot product left side with 0 degrees, dot product right side with 0 degrees, what do you have? You have negative AG is equals to negative alpha RAG. This thing will become 0. And eventually we prove that acceleration of G is equals to alpha RAG. Okay? So this is actually a very special condition. And this condition arises most importantly because of the rolling without slipping condition of the wheel and the ground. It's based on a very simple understanding that the ground cannot have any acceleration or any velocity. When the ground does not have any velocity, it means that velocity of A must be 0 to it because VA prime is 0. When VA is 0, VA prime is 0 according to this velocity relative term, velocity of G must be equals to R omega. And since we know that the direction of the acceleration of A must be pointing upwards due to it having a 0 acceleration component along the rolling without slipping plane, as AA prime has a 0 acceleration along the what is called rolling without slipping plane, we can definitely say that acceleration of A is pointing upwards, which is 90 degrees. And we also know that preconditionally, acceleration of G must be pointing horizontal, so it's 180 degrees. So from this manipulation, we dot product both sides with 0 degrees and we reveal this answer. But if you do not know how to dot product, it's fine. You just resolve everything to the horizontal direction. And eventually you get the same answer. You resolve everything to the horizontal direction, what you do is that you just cos everything. Right? You cos everything, this will become 0, and eventually you get AG equals alpha RAG. The same thing. Alright? So that's basically a very brief introduction of rolling without slipping. I hope you have more understanding of this. I think we'll go to the final question in tutorial to answer the question.